Hi Calculus student, this video is for chapter 3.9, derivative of exponential and log function. And in the last video, we talked about the formula. If I have d dx e to the x, then it's e to the x. If I have d dx ln x, then it's 1 over x. And if it is not just x, that would be a chain rule kind of question. We would say g of x is the inside function, so we do the derivative of this would be e to the g of x, just the same thing, multiply with the derivative of g of x. And then for ln, it will be 1 over the inside g of x times g prime of x. So we have a few more derivatives that we want to do that involve e to the x function and also ln. So this is a e to the x function, but you can see that it's a quotient, right? So we'll say f is e to the x squared, and g is just x in the denominator. So f prime would equal to, when I do this, I have to do the chain rule, right? So you'll be e to the x squared times 2x. You write e to the inside times the derivative of inside. G prime would be 1. So the derivative of this dy dx would equal to x squared in the denominator, fig minus g, right? Gif, fig, this 2, e to the x squared times x. So x e to the x squared. Subtract gif, g prime, which is 1, times e to the x squared. So you can see that e to the x squared shows up twice, so you factor it out, x minus 1 over x squared. That is the derivative of that. The second is the derivative of y equal to ln 2x cubed plus 4. So you can see clearly this is the inside, and we have ln chain rule, inside, outside. So the derivative of this would be, what is the derivative of ln? It's 1 over whatever that is inside. 1 over whatever that is inside. And then the chain rule of derivative of this, d dx of 2x cubed plus 4. So 2x cubed plus 4, so you can think of it as the 2x4, 2x3 plus 2x to the cube plus 4. The denominator, the numerator would be the derivative of this, which is 6x squared. And 4 will become 0, and that's it. That's the derivative of that. The fourth one is we have e to the x and sine x together, which is a product rule. So let's say f is e to the x, g is sine x. This seems to be very easy, doesn't involve any like chain rule stuff. So f prime is just the same thing. I don't have to do a derivative because it's just e to the x. And g prime is cosine x. So when I do dy dx, fig plus g again, fig e to the x sine x plus gif cosine x e to the x. Again, both of them has e to the x. You can factor it out. Sine x plus cosine x. And then we have two more. Maybe I'll do this in class. This one is a product rule, and this is a derivative of a ln, but the ln inside is a square root. So this is in itself another chain rule. So this, you can treat it as, multiple chain rule being applied. So we'll do it in class. And so what is the next things that we can do? So we have two more. So 7. Let's do a derivative of y equal ln x over x. Okay, and then question 8 is a very interesting one that you should pay attention to because it can be useful when we have a technique called logarithmic differentiation. So let's do example 7. To get the pencil, because the pencil is not enabled, and also I need to make this a little bigger. Okay, so example 7 of 3.9. Y is ln, so I just say do it here. Y is ln x over x, so it's a quotient, right? So we'll do it here. F is ln x, g is x, F prime is, remember, what is ln x? It's just 1 over x. What is g prime? It's 1. So dy dx would be g squared, x squared. And the top is fig minus gif. 1 over x times x. Oh, 1 over x times x. That cancel, become 1, right? Minus gif. G prime is 1 times ln x. So this is just ln x. So this cancel, become 1 minus ln x in the top. And the bottom is x squared. Number 8. Example 8. The derivative of ln x squared sine x over 2x plus 1. You might be very surprised because this is a big quotient. So this is inside, of course. The derivative will be 1 over this whole thing, which is not hard, times the derivative of this. But the derivative of this is really difficult. So you are dragging on doing, you don't want to do this. But we have to pay attention to the fact that this is ln of a whole bunch of products. Due to log properties, if I have ln a times b inside a log, I can split it as ln a plus ln b. This is very important, right? We call it the product properties of log. So I have, and then if it is dividing, it is subtract, right? So I have 2 multiply and 1 divide. So in order to avoid doing those very difficult quotient rule, what we can do is, instead of doing it right away, we would say, I'm going to do d dx of not the whole ln, but rewrite it as ln x squared plus ln sine x, because this is a multiply inside the ln minus ln 2x plus 1. And let's see if we can simplify better. ln x squared power rule, I can move the 2 out. So it's actually, if you want to, you can actually just do a little bit more. 2 ln x. This is also the log properties, right? ln of a to the p power is equal to p ln a. So if I have x squared, I can do 2 ln x plus ln sine x. We cannot simplify anymore. Minus ln 2x plus 1. We cannot simplify anymore. It's just one term. So now we're ready to do it. So 2 ln x would be 2 over x, right? ln x is 1 over x. Plus, what is this? This is inside is sine x. That's the g of x. So outside is ln. There will be 1 over sine x. And then do a d dx of sine x. Minus, what is this? This is 1 over 2x plus 1, right? Because inside a log. So do d dx of 2x plus 1. Whenever it is not x itself for ln and e, you have to just do the derivative inside. So 2 over x plus, what is this? Sine of this would be cosine x over sine x, no more log, minus 2x plus 1 in the denominator. The numerator would be d dx of 2x is 2. And that's the final answer. You can simplify this as cotangent also. Right? Cotangent x. Cosine x over sine x is cotangent x. So make use of the fact that if you have ln a whole bunch of stuff inside, unless it is a add or subtract, you can't split it anymore. If they are products or quotient, you can split them. And we'll use this fact later. The second part is if I don't have ln x or e to the x, but it is a b to the x. I want to do d dx of like 2 to the x or 5 to the x. What is the formula? The formula would be b to the x ln b if the base is b. And for log will be 1 over x ln b. So these are the derivative rule. And you can also have chain rule. That means if the inside is not just x and b to the x, the exponent is not just x, but it's g of x, then we just do g prime of x in the top. And at the denominator is gx ln b. For b to the gx, it will be b to the gx, just like e to the gx, g prime x, and then also ln b. Okay, so let's do this field question example. If y is 3 to the x, find a derivative. So we would say dy dx. Oh, this is just 3 to the x, so it will be use the one that we have earlier. Just equal to 3 to the x times a ln of 3. ln of 3, and that's it. If this was e to the x, I just do e to the x. But if it is not e, then you have to multiply ln of that number. It's very simple. So what about this? This is a log, but log 4, not ln. And the inside is not just x now, it's a g to the x. Outside is log, inside is x squared plus 4. So I do chain rule. So dy dx, the chain rule as specified here. This is actually the chain rule. So if I do dy dx, what does it look like? So it would be 1 over whatever that you have inside, x squared plus 4, times d dx of that it is inside. We always do the derivative of it. So if you do derivative, that is 2x, right? And then x squared plus 4, and that is the derivative. Oh, but this is the ln. This is not ln, it's 4, so we have to times at the bottom, look at the rule. ln b, ln 4, times 1 over, is it 1 over or is it multiply? Yeah, in the denominator ln 4 also. So I should actually do it earlier, 1 over ln 4. So I should have x squared plus 4 ln 4. The 4 is because the base is 4. Okay, let's do to the next one is 2 to the 4x plus 4x squared. Okay, so this is an exponential. This is just a power rule. I put them together so you can distinguish them. 2 to the 4x. This is the base is 2. So, but then the x is not x, is 4x. So you have to do some kind of chain rule. So d dx, dy dx would equal to still 2 to the 4x. But because this is not x, so I have to do, oh, because the base is 2, so I have to ln b, ln 2, the base is 2, times d dx of 4x. The last part is just power rule, so I would just say, 8x. This is the power rule, right? Because x is there, this is the constant. So let's move this together. So 4x, the derivative is 4, right? So I have 4 times ln 2, and then times 2 to the 4x plus 8x. Some answer key would actually move this 4 inside, so it'll be ln 2 to the 4, so that means ln 16 also. So some book would move everything inside. 16 times 2 to the 4x plus 8x. We have 2 more, so do we have enough time to do both of them? Let's just do one. Maybe the last one, we'll do it in class. So y is log sin x. If you have log but no base, that means the base is 10. Base 10. Okay. So we would do the inside is sin x. So dy dx would be 1 over the inside, 1 over sin x. And then because it's log base 10, so we say ln 10. Okay. Times what? D dx of sin x. So d dx of sin x is cosine x over sin x ln 10. That's the answer.